because we are striving for excellence in all things, not just sport, right, Pippins? Let's go. All right, number one, here we go. List the domain of the following. All right, so these are all our domain questions. What does the test look like?
Same thing.
Uh-huh. So we better be able to do this. All right, you will do this however it makes sense for you to do it. I will do it by following my rules. What are my domain rules?
The denominator to zero.
Denominator cannot be zero. So here's a denominator, cannot be zero, so x cannot be 6. Now, in a minute, I'm gonna go back and I'm gonna fill in the answer blanks. But right now, I'm just getting down. What are my rules? No denominator, no denominator. Oh, here's a denominator. X plus 7 cannot be 0, so x cannot be -7. That is rule 1. All right? What is my second rule? If it's under the radical, it has to be bigger than or equal to 0. All right? No radical. If it's under the radical, it has to be bigger than or equal to 0. So the green is one rule. The brown is the other rule. There's only 2 rules. So now I'm ready to write my answer. Okay? So, guess what? For this first problem, put both of these in the answer blank, and that's your answer. These are the answer, both of those. It's a 2-part answer, because we have both rules at play. So that's our answer. Put that in the answer blank. What about this one? I don't even have anything written down for this one, so what does that mean? Negative infinity to infinity. That's what you're gonna write in the answer blank. Right there. Now this one, if you write that in the answer blank, you're gonna get most of the credit, but if you wanna get full credit, you have to recognize that's an interval right there. What is that? -5 to infinity. This one you can just leave just like that. The not equal to's, you can just leave alone. So there we go. That's part 1. Everybody okay with that?
Mm-hmm.
All right, now we're going to part 2. I'm going to erase this now. Everybody got it? Answers are in Canvas too, if you need to go back and look for them. All right, so now we're going to find all the asymptotes and holes. So vertical, horizontal, holes. All right, so what are we going to do first? We're going to factor, right? So we're going to have 2x plus 9 over what? How does the bottom factor? -4 plus 1? Now, we needed to do that, but nothing cancels. Okay? So what does that mean? If nothing cancels, that means
No holes.
no holes. So we just write none here. Don't leave it blank. If you leave it blank, it looks like you don't know what you're doing. Write none. All right, now let's look at our denominator. 2 things down there. What does that tell me? two vertical asymptotes. Because where do vertical asymptotes come from? The denominator. So my vertical asymptotes are 4, x equals 4, and x equals -1. Straight from the denominator. Where do vertical asymptotes come from? The denominator. Okay? Now, horizontal asymptote. Take a look at the original problem. What do you notice? The x's don't match. You can't box them in. The one on the bottom is bigger. When the one on the bottom is bigger, it means your horizontal asymptote is at 0. We can keep talking about this, you guys, but you have got to study it. Okay, next. Same thing, we're gonna find all the asymptotes and holes. Now, what do you notice about these powers? They match. So I can box those in, and what is x squared over x squared? Y equals 1. 1 over 1. Right? Okay. What do you want to do now? Got that part figured out. What do you want to do?
Vertical asymptote.
Well, I can't do my vertical asymptotes until I do what?
Factor.
Oh, yeah, factor it first.
I gotta factor it. So, +3 plus 2, and +3 minus 5. And then I will double check my factoring, make sure it's right. By foiling. I think I'm good. And what do I notice? I can cancel. So what does that mean, the fact that I canceled? I'm gonna have a hole, and the hole is gonna be where x is -3. How do I find the y?
You plug it in.
Plug it in. So -3 plus 2 is -1. And -3 minus 5 is -8. So 1/8. Now this is what I have left when I cancel. Do I still have a denominator? I do. So I still have a vertical asymptote, and it will be x equals 5. Here we go. One more, just like it. So we're gonna find vertical. Horizontal and holes. Alright, let's look at the horizontal asymptote right here. Do they match? X squared, x squared? Perfect. Box them in and get what? X squared over x squared is? 1. So your horizontal asymptote is 1. X squared over x squared. Now, to find the rest of it, I'm gonna have to do what? Factor. So, x minus 4 plus 4, x minus 1 plus 1. Well, I did a whole bunch of factoring, but what?
No holes.
No holes. None. Because nothing canceled out. Do I have a denominator? I actually have 2, right?
So 1 and -1.
So my vertical asymptotes are x equals 1 and x equals negative. Alright, now we've got a sketching section. This one is worth more because it's more involved than the rest of the sketches, they're easier. This one's worth more. So what's the first thing you're gonna do probably when you look at this problem? I would put the crack into the picture. This is a piece, right? It's in pieces. Like a plate, when you break it, it's in pieces. So what the break, the crack, is gonna happen here at -2. What does x squared look like? Parabola at the origin. And it's gonna hit right there. And that dot will be a closed dot. Look, closed. And which part of the parabola will I keep? The way it's pointing. It's pointing that way. So I'm gonna keep the right side and get rid of the what's that? Isn't that your linear?
Yeah.
Down one?
Yep.
It hits right there. That will be an open dot. And what part will I keep? The way the arrow's going. The arrow's going that way, so I'm keeping that and getting rid of that. So I'm gonna go ahead and erase my squiggly, but you don't have to. Picture looks better if you erase it, but you don't need to. There it is. The two pieces of your function. Alright, the dots are always on top of each other. Some of your homework, we have dots over here and dots over here. No. They're always on top of each other. I'll get that back to you. Okay. Alright, let's do the rest of the graph. Remember, there's only 5 parts to this whole test. You're on part 3 right now, your graph. So tell me about this guy. What shape? Problem.
Yeah.
Half credit for having the right shape. Okay? Now tell me where that parabola is.
Up to right one.
So right one, up to, and label that point, and drawing my parabola. Easy peasy. How about this one? What shape is he? A V? Situated where? Left one, up one? Everybody see that? Left one, up one? I did not write that very well. That means this. E to the x plus 2. Alright, so we know what e to the x looks like. E to the x looks like this. up 2. So that means this guy, this asymptote right here, has to go up 2. So now he's up here. He was on the x-axis. Now he's up 2. That point was at 0, 1, but now it's at 0, 3. And then I have my shape. So this is the answer to the question. I always draw the original so I get a visual, but you don't have to. This is what you have to have though on your paper. Here's another one where I'm going to draw the original. The original is a cosine. Is that okay with everybody? That's my original cosine. Bouncing back and forth between -1 and 1. Now, what am I going to do here with this cosine? Down 2. All right, so think about that. Everything's coming down 2. So the starting point, which was at 1, is now going to be at -1.
Yeah.
And it's going to come down 2. It's going all the way down now to -3. Because it used to go down to -1. It's going down 2 more. So the black one is the answer. And I am perfectly okay with you doing it like this. Just make sure I know which one is your answer. So the answer is my black one. The green one was the original function. All right, one more graph. What shape is this one? Oh my gosh, Mrs. Ford got wild and crazy. All right, let me erase this for a second. Let me get that up. What's that one? Up and out, starting 2 to the right. Okay, so I'm gonna graph that. 2 to the right, 2 0. Goes up and out. But there was a negative in front of it. That is not fair. What does a negative in front do? That's flip it upside down. So this is gonna go upside. So instead of going up and out, it's now gonna go down and out. No. So that is your answer. So what if we had a V? What if we had a negative in front of a V? What would that do? Turn it upside down, make a V down this way. All right. Now we're at the function part. So we have P function and a Q function. And we're going to find P of X times Q of X. If you make this hard, I don't know what I'm going to do. This is not hard. This just says take P, which is 2x squared, and times it by Q, multiply it. This is a multiply. So we end up just distributing. So negative 6x cubed plus 2x squared. Don't make that exactly right. I take the p function, the whole thing, the whole p of x, and I plug it into the x in the q function. So negative 3 2x squared plus 1. Negative 6x squared plus 1. Take the p equation, the whole equation, 2x squared, and plug it in to the q. Alright, what about the next one? What does this mean? What does that mean? Plus 2 into p, and do that carefully. When you put 2 in there, what do you do first? Square, MDOS. So 2 squared is 4, times 2 is 8. So p of 2 is 8. Q of negative 1, carefully, when you put negative 1 in there, what do you get? Well, this part's 3, but then you have to add 1, so you get 4. So the answer to the problem is 12. Write each one individually, and then add them together. And then finally, what is this?
You would just put 0 for, yeah, the negative 3.
0 in the Q. What do you get when you put 0 in the Q?
1.
1. Then take the 1 and plug it into P.
Yeah.
And what do we get?
2.
2. You're not getting 2, you're not doing it in the right order. You plug something in, you gotta square first, and then times 2. 1 squared is 1, times 2 is 2. Alright, one more part, number 5. Find the implicit functions. Notice I have 2 answer blanks. How do I find the implicit functions?
Get y by itself.
Get y by itself. Now, in case this is easy, but you gotta do it carefully, you gotta pay attention. You subtract x squared. You're left with negative y squared equals 25 minus x squared.
Yeah.
Then we have to divide by negative 1. So y squared is negative 25 plus x squared.
Square rooted.
Square root it. So your 2 answers are
Y plus or minus.
negative, the square root of negative 25 plus x squared. And negative the square root of negative 25 plus x squared. Oh my gosh, what is this number 6? What is that? I don't know either. Totally not fair. We have 5 parts to the test. We've done 5 parts. I wonder what this might end up being.
Bonus.
Oh, I don't know. We'll run through it one time. Not going to answer any questions about it. We're going to do a little more review. But I will run through this. This says that there are 2 functions out there. There's an M function and an N function. And when I put the N into the M, that's what I end up with. So you see that? This means put N into M. Someone's already done that and gotten this answer. The question is, what do the M and N have to be? Well, it's easy if you think about it. Two things are happening in this problem. We are multiplying by 3, and we are subtracting 7. Do you agree with that? And we're doing it in that order. If I said plug in 2, wouldn't you multiply first and then subtract? So this is what M and N have to do, and they have to do it N first. So the first thing that happens is we multiply by 3. So N is the function that multiplies by 3. M then has to be the function that subtracts 7. So here is your answer. Because if you put N into M, don't you get 3x minus 7? You sure do. I'm not going to take any more time with that. That's there. What I'm going to do now, okay, so we have a short period. We just took the entire test with me blabbing around, and we still have 10 minutes to go. So you will have plenty of time tomorrow. But I want to do a little bit more graphic, because I remember from last year that this is where we lost a lot of things. Now there's you're quiet today, Brian.
Me?
Yeah,
I answered like,
I know.
like 5 questions.
I know. But it's not, usually you answer everything. All right, let's take a look at these. 10 graphs. So these are all BFFs, and they move. So, do you see any that you want to do? Which 2? Oh, 2 is easy. What shape is 2? Okay, well, it's not going to be easy if you can't remember what shape number 2 is. A parabola. What? Oh. And where have I put the parabola? Oh, it's a loop. Oh, no. This is number 2. Number 2 is a parabola, 2 to the right.
I'm sorry, I was looking at
Jason,
That's a parabola, 2 to the right. Number 2. All right, what's another one you need to do?
number 7.
7. What shape is number 7? It's a squiggly.
Yeah.
And normally, the squiggly, that is this parabola and that parabola, normally it's at the origin. But this one will be 2 units to the right. So there's the down parabola, and there's the up. There it is. 2 units to the right. 3 is your logarithm. That one is not as common for us. So I'm going to go ahead and draw it. The standard basic logarithm has an asymptotic 0, a point at 1, goes like that. That is my normal logarithm. I am doing problem 3. So what has changed?
+1, so up 1.
To the left one.
Left 1.
Oh, it's inside the parentheses.
Gotta pay attention. Left 1, right? So, this asymptote asymptote that used to be right there on the axis is now gonna be at -1. Right, back up 1. And the dot, which was at 1, is now gonna be at 0. And the shape is going to be exactly the same. It's just all been shifted over 1 to the left. All right, what else?
Can we do 4?
4.
Yeah. I think I know how, but I just want to see it.
The normal exponential has an asymptote to 0, point at 1, it looks like this. That is the normal. What have we done?
Down 2.
Down 2. So I'm gonna do it on the same grid here. I'm gonna drop everything down 2. So now the asymptote is down here at 2. Right? Crosses the y-axis at -2. Sorry about that. Negative. And then that point, which is at 0, 1, is now gonna be at 0, -1. And the shape isn't changing. So the blue is the answer. The green is the original, kind of giving me a guideline, but the blue is my final answer. All right, this one right here was number 7. Look at number 10. What's number 10 look
That's the
Like
squiggle.
those, yeah.
It's a squiggle. It's the 2
like? 10 is the same thing, except it's been moved up 2. So now the squiggle will be here. So there's my down parabola, and there's my up parabola. So 7 and 10 are exactly the same shape. This one went right, that one went left. All right, turn it over. Did you grab LNX? What does LNX look like?
Log.
Asymptote. Yeah, right? That's LNX. What is 1 over x? I don't think we've done anything with that one today. What does 1 over x look like? That's the reciprocal. That's the one that's in 2 pieces, right? All right, and what about, oh, we know what x squared looks like. X squared is the parabola. All right, what equation is 2a?
It's y equals cosine.
Cosine x, that's exactly right. Y equals cosine x. What about b?
It's absolute value.
Absolute value x, that's exactly right. And c is our friend the reciprocal again. Y equals 1 over x. Yeah. You don't need to worry about number 3 down there at the bottom. You don't need to worry about that. All right, that's it. I think we're good. We have a test next time I see you, right? Wednesday. Wednesday is the day. So you'll be right before lunch on Wednesday. If you're going on retreat, you can take the test any day that we have office hours the following week. And or after school the following week. So any day, just come in. You don't need to make an appointment. Just come in. And this test is short enough. If you come in at 8, you should have plenty of time to get done.